Hello students, welcome to Brilliant Group of Institutions, Qatar. So I'm going to now continue with the indefinite integrals topic 2. Method of partial fractions in integration. So now the problem is to identify a question in which I can use method of partial fractions. So we have to always ask ourselves, when do we use method of partial fraction? So method of partial fractions, when is the method of partial fraction used? We use method of partial fractions in the integral of the form p of x divided by q of x. P of x divided by q of x. And you have to be very particular, p of x and q of x are polynomial functions. P of x and q of x are polynomial functions. Not only that, the q of x in the denominator should be a factorizable polynomial and the factors should be of degree 1 or 2. We cannot have a factor of more than degree 2. The method of partial fraction that we are learning is only accommodating factors of degree 1 or degree 2. Not only that, we have to keep something else also in mind, that is the degree of p of x. The degree of p of x should be less than the degree of q of x. The degree of p of x should be less than the degree of q of x. So once again, keep two things in mind. When do we use method of partial fractions? When we are doing integrals of the form p of x by q of x, where p of x and q of x are polynomial functions, the first thing. Second thing, q of x should be factorizable, where each of the factors should be of either degree 1 or 2. Third one, the degree of the numerator p of x should be less than the degree of the denominator. These are the three things that you should keep in mind. Only then can you use method of partial fractions. Okay. Now, let's go for the method now. So we have to learn these important conversions. If you want to use the method of partial fraction. So the conversions are based on what are the factors that they give in the denominator. If the denominator have simple factors like degree 1 factors, these are factors of degree 1. These are degree 1 factors. These are all degree 1 factors. X minus a, x minus b. Then the partial fraction form is a by x minus a plus b by x minus b. That is, each simple factor is associated with an arbitrary constant a, b, c and so on. So here we have only two factors. So a by x minus a plus b by x minus b. The second type is when we have repeated factors. That is, if I have a factor which is repeating, how many times it is repeating? 2 times. X minus a squared. Then how do we assign the arbitrary constant? A by x minus a, b by x minus a squared, c by the remaining factor x minus b. So the repeated factor, like if it is repeated 3 times, then you have to use 3 arbitrary constants: a by x minus a, b by x minus a squared, c by x minus a cubed. Okay, so we can have repeated factors. How many number of times we want, that many times it can repeat. But you have to keep on writing that many number of arbitrary constants. So maximum number they can ask you is 3, but very often it is only 2. And the third one, quadratic factor. But keep in mind, whenever they ask these two, repeated or quadratic, only one repeated factor. This is what I want everybody to keep in mind. We can have only one repeated factor and only one quadratic factor. Is it clear? At a time, partial fraction can accommodate only one repeated factor and one quadratic factor. That is what you have to keep in mind. So there are questions where are two quadratic factors coming, that we will discuss during the questions. Okay. So how do you accommodate a quadratic factor? Whenever you're accommodating a quadratic factor, the numerator should be a linear form ax plus b. Arbitrary constant ax plus b, a linear form. And please keep in mind, though I have written this ax squared plus bx plus c, the only quadratic factor they are going to ask you is x squared plus a. The only quadratic factor they are going to ask you is x squared plus a, nothing else. X squared plus a, which is not factorizable, Keep in mind, simple factors, repeated factors, quadratic factor. Okay, and how do you associate with an arbitrary constant? Simple factors, one arbitrary constant. Repeated factors, that many arbitrary constant based on the number of times it is repeating. If it repeats 2 times, 2 arbitrary constants. 3 times, 3 arbitrary constants. Okay, but for a quadratic factor, you associate with a linear form ax plus b in the numerator divided by the quadratic factor, and the quadratic factor which they are going to ask you is only x squared plus a. X squared plus a. Okay, next one. What happens if the degree of the polynomial p of x in the numerator is greater than or equal to the denominator? I told you partial fractions can only be done if the degree of the numerator is going to be less than the degree of the denominator. So what happens if degree of the numerator is greater than or equal to? Then you will simply divide these 2 polynomials. You will simply divide these 2 polynomials. So when you divide these 2 polynomials, you will always get, so like let's say, 1 minute. Let's not say p of x by q of x. Let's say p of x by g of x. Okay, p of x by g of x. Okay, I'm just changing this so that I can say something here. So when you're dividing these 2 polynomials, I will obviously get a quotient q of x and a remainder r of x. You will always get a quotient q of x and a remainder r of x. Then this p of x by g of x, p of x by g of x can be now written as the quotient q of x plus the remainder r of x divided by the divisor g of x. This is how you will write it. Okay, you will write it like this, and then here you will do normal integration. Here you will do what? You will do normal integration. Okay, but in the second part, what you do? In the second part, you will do method of partial fractions. Method of partial fractions. In the first part, you will do normal integration, but in the second part, you will do method of partial fractions. Everybody clear? Yes. So whenever we are dividing 2 polynomials, you will divide it and express it in the form of q of x plus r of x by g of x, and that is going to be the first part normal integration, the second part method of partial fraction. The second part is the method of partial fraction. Okay, everybody clear? Yes, we will do a question of this type also. Let's start with the question discussions now. Let's start with the important questions that are going to be discussing about method of partial fractions. Okay, very easy. So the first one you can see over here, it's like simple factors, all of you. Can you see that these are simple factors? There are no repeated factors, there are no quadratic factors, these are simple factors. So how do we approach with this method? All of you look at it, we'll take the expression 2x plus 1 divided by x plus 2 into x minus 3. 2x plus 1 divided by x plus 2 into x minus 3, and that will be splitted using the arbitrary constants a by x plus 2 plus b by x minus 3. This is how you will split your simple factors. Yes, using simple arbitrary constants a by x plus 2 and b by x minus 3. Okay, and then we are just taking the LCM on both sides, or like you can take this complete denominator and multiply over here. You can think whatever way you want, taking LCM or simply multiplying the entire denominator to a and b, then your expression is now going to be rewritten as 2x plus 1 is equal to a into x minus 3 plus b into x plus 2. Okay, a into x minus 3 and b into x plus 2. Now, what is the method of finding a and b? Like in the previous linear by quadratic topic which I've discussed in the previous session, you can also just go back and find it. You can use method of comparison, fine, but method of comparison here is more difficult compared to the method I'm going to teach you now. Here what you can do is, you can simply look at your factors. The first factor is x plus 2. In that x plus 2, you just think what is the value of x which makes it 0? Minus 2, right? If I put x is equal to minus 2, it becomes 0. So you decide it like that. Okay, in the first case, I'll say put x is equal to minus 2. If I put x is equal to minus 2, this I'm going to call it as equation number 1, and this I'm going to call it as equation number 2. So my equation number 2 implies 2 into minus 2 plus 1 is equal to a into minus 2 minus 3 plus b into 0. That is the beauty of this method. Once you substitute it, you can directly get the a over here. That is going to be minus 4 plus 1 is minus 3, a into minus 5. That implies a is equal to 3 by 5. A is equal to 3 by 5. Okay, now next one, we're going to put the next value of x. Okay, the next factor is x minus 3. We have to put x is equal to 3. The next factor over here is x minus 3. In that we have to put x is equal to 3. Then if I put x is equal to 3, what happens to equation number 2? What happens to equation number 2? Equation number 2 implies 2 into 3 plus 1 is equal to a into 0 plus b into 3 plus 2. That implies 6 plus 1 is 7 is equal to 5b. That implies b is equal to 7 by 5. B is equal to 7 by 5. So I found out the two arbitrary constants. So now I will look at equation number 1. Equation number 1 implies integral of 2x plus 1 divided by x plus 2 into x minus 3 is equal to integral of a. A is 3 by 5. 3 by 5 divided by x plus 2. And b is 7 by 5. 7 by 5 divided by x minus 3. Okay. So the answer is going to be 3 by 5. And what is the integral of 1 by x plus 2? Log mod x plus 2. 7 by 5 log mod x minus 3 plus c. Log mod x minus 3 plus c. Very easy. So everything is dependent on the partial fraction. Once partial fraction is done, very easy integration. Okay, now in method of partial fractions, very common integration results are going to come. So one of the common three integration results, I'm going to say that now. Look at it. I'm going to say the three integration results. You're going to see here 1 by x plus or minus alpha is equal to log mod x plus or minus alpha. This is the first integration result that you will see in integration of partial fractions. Okay, next one, 1 by x plus or minus alpha power n or power 2 power n. Okay, the repeated factor integration. So answer is going to be x plus or minus alpha power minus n plus 1 by minus n plus 1. This is what the answer is. X plus or minus alpha minus n plus 1 by minus n plus 1. Keep that in mind. Finally, the last one, 1 by x squared plus a squared form. That is 1 by a tan inverse x by a. These are the only three forms that is going to come. These are the only three forms that is going to come in integration using partial fractions. These are the only three forms that is going to come in integration using partial fractions. Okay, so the three forms are ready. Yes, so now let's go for the next question. Okay, you can easily see that one of the factor is repeated. I told you if repeated factor comes, only one is going to be repeated, not all. You can see over here, it's a repeated factor. Yes, this is a repeated factor. So how do you address a repeated factor? I hope everybody remembers How do you address a repeated factor? The repeated factor is addressed by 2 arbitrary constants because it is repeated 2 times. So it's going to be x divided by x minus 1 squared into x plus 2. Repeated factor. So a divided by x minus 1, b divided by x minus 1 squared, and c divided by x plus 2. A by x minus 1, b by x minus 1 squared, and c by x plus 2. And what is the method I told you? Take the denominator, multiply it to a, multiply it to b, multiply it to c. Then you can easily write the simplified form. So call it equation number 1. Call it equation number 1. So what is going to be the answer for x? X is equal to a into x minus 1 x plus 2. Okay? b into x plus 2. c into x minus 1 squared. And call this as equation number 2. Call this as equation number 2. And in the previous question, I told you how to find the arbitrary constants a, b, and c. How do you find it? You can simply look at the factors and substitute the value of x, which makes it 0. You can get 1 by 1 arbitrary constants, right? Tell me how many factors we have here? Only 2. X minus 1 and x plus 2. So that means you're going to get only 2 arbitrary constants. Third one is going to be missing. Okay? So careful here. Put x is equal to 1 because 1 makes it 0, right? So equation number 2 implies 1 is equal to a into 0, b into 1 plus 2, and c into 0. That implies 3b equal to 1 implies b is equal to 1 by 3. So the first value of x gave me the arbitrary constant b. Now look at the next factor. The next factor is x plus 2. The value of x which makes it 0 is minus 2. The value of x which makes it 0 is minus 2. You put x is equal to minus 2. X is equal to minus 2. Equation number 2 implies minus 2 is equal to a into 0 plus b into 0 plus c into minus 2 minus 1 squared. Minus 2 minus 1 squared. That implies minus 2 is equal to 9c. Minus 2 is equal to 9c. That implies c is equal to minus 2 by 9. C is equal to minus 2 by 9. So very happy with 2 arbitrary constants, but not the third one. How do I find the third one? That is where we need the traditional method. What was the method we used in the previous topic of particular functions where we found out the arbitrary constants a and b? Method of comparison. Why did I not use that here? Because there are only 2 arbitrary constants. Now 3 arbitrary constants, 4 arbitrary constants can come here. So it will be more complicated to find it. It's easier to put something and make it 0 and get the answer. That is why this method is used here. Okay. The third one will be like comparing terms. Compare. See, I'm going to compare the x squared terms. Compare the x squared terms. So when you look at it, the left hand side has 0x squared. The left hand side has 0x squared. Can you see there are no x squared terms on the left hand side? On the left hand side, there are no x squared terms. But when you come to the right hand side, you can see that there is an ax squared. Ax squared. Okay. And then you can see there is a cx squared. Ax squared plus cx squared. So I can say that implies a plus c equal to 0. That is, a is equal to negative c. A is equal to negative of c. C is minus 2 by 9. So negative of c is positive 2 by 9. A is equal to positive 2 by 9. A is equal to positive 2 by 9. So based on that, we're going to do equation number 1. Therefore, equation number 1 implies the integral of x by x minus 1 squared into x plus 2 is equal to a. A is 2 by 9. So integral 2 by 9 with x minus 1. Okay. Then b is 1 by 3. 1 by 3 with x minus 1 squared, and then we have c as minus 2 by 9, c as minus 2 by 9 divided by x plus 2. Okay, I told you in the previous question itself what are the different forms of integration you are going to face. One is 1 by simple factor, 1 by repeated factor, 1 by quadratic factor. You have a simple factor and a repeated factor form here. You have a simple factor and a repeated factor form here. That is equal to 2 by 9 log mod x minus 1, 1 by 3. The repeated factor, how do you handle power of n? It is like x minus 1 power minus 2 plus 1 divided by minus 2 plus 1, and again it's going to be a simple factor, minus 2 by 9 log mod x plus 2, log mod x plus 2 plus c, log mod x plus 2 plus c. That is equal to, making it better, 2 by 9 log mod x minus 1, and this is going to be minus 1 by 3 into 1 by x minus 1, and minus 2 by 9 log mod x plus 2, log mod x plus 2 plus c. This is the answer for the question. This is the answer. What is the additional thing that happened in this question? That is, how did you utilize the repeated factor? How did you utilize the repeated factor? You utilize the repeated factor as what? You utilize the repeated factor as two different factors, right? You utilize it as two different factors, and then finally the third arbitrary constant cannot be found out by the normal method of substitution because there are only two factors. So what I did is I did the method of comparison. So whenever you're facing a problem, you always use method of comparison. I compared the x squared terms and got the answer. Okay, fine. Let's go for the next question. Okay, now this is one form where you can see that the denominator is a polynomial, numerator is also a polynomial, but it is not in the factorized form. It is not in the factorized form. So I'll not be solving the entire thing. I'll be showing you how to factorize it. It is similar to the question that we did before. All of you, please look at it. It's a cubic form in the denominator. So I will write it as 3x plus 5, 3x plus 5 divided by x cubed minus x squared minus x plus 1. Okay, this is what the denominator. This is a cubic form. I have to make sure whether it is factorizable. Okay, if it is factorizable, then I can definitely use, if it is factorizable, I can definitely use the method of partial fractions. If it is not factorizable, you're into big trouble. It's very difficult to solve it. Okay, method of partial fractions. So let's see now. X cubed minus x squared minus x plus 1, and in the first two terms, I can see x squared is common. So if I take x squared common from that, I have inside the bracket x minus 1, x squared into x minus 1, and then I have a minus 1 over here. If the minus 1 comes out, it is going to be x minus 1. Yes, from the next two terms, take out minus 1, it is going to be x minus 1. And then look at it. I have an x minus 1, I have another x minus 1. I can take a common out, right? That is going to be x minus 1, and inside the bracket it is going to be x squared minus 1. Don't think that it is quadratic. X squared minus 1 is still factorizable into x minus 1 into x plus 1. That is actually x minus 1 squared into x plus 1. I will not be solving this entire thing because the answer is very crystal clear now. This answer is going to be like 3x plus 5 divided by the repeated factor x minus 1 squared and a simple factor x plus 1. That is going to be a by the first factor x minus 1, b by the second repetition x minus 1 squared, and c by the third simple factor x plus 1. Then we have to use our normal method of partial fractions like we did in the previous question to solve it. So this question is for what? is to teach you that if whenever you have a polynomial by polynomial form, it is highly expected that it is going to be method of partial fractions. For that, the degree of the numerator should be less than the degree of the denominator, and the denominator should be a factorized form with simple and quadratic factors. Okay, so I believe everybody can continue from here. So let me not waste the time by doing this again. We have done a similar question in the previous part. I think you can do it. Okay, so let me move on to the next one. Okay, now we are facing a big trouble. What did I tell you about being a quadratic factor? What did I tell you about being a quadratic factor? Only one quadratic factor is entertained at a time in method of partial fractions. Okay, so remember, here there are two quadratic factors. Here there are two quadratic factors. Here there are two quadratic factors. Got it? Here when you look at the denominator, I can see there are two quadratic factors in the denominator, which cannot be done directly with method of partial fraction. What is the most easiest method is, we will do partial fraction definitely, but we will do it after doing a simple substitution. Look at the method I'm going to use here. I'm taking the integration form, x squared divided by x squared plus 4, x squared plus 4 into x squared plus 25. This is the two factors they have given me. Then what do I do here? I will say let x squared is equal to t. If I put x squared is equal to t, then this expression is going to be t divided by t plus 4 and t plus 25. I'm not doing the method of substitution which you usually do in integration. No. I'm just doing the substitution only in the partial fraction method. Okay, keep in mind, I'm not doing it the normal integration method of substitution. That is, you have to do the derivative and resubstitute dx and dt and all, but not that. I'm doing this as a simple substitution in the partial fraction. And then, so this can be written as a by t plus 4 and b by t plus 25. A by t plus 4, b by t plus 25. Okay, and then what you do here, we will take the denominator and we will multiply it to a and we will multiply it to b. Multiply it to a, multiply it to b. So my answer is going to be t is equal to a into t plus 25 and plus b into t plus 4. So I have my two forms, equation number 1 and equation number 2. So in equation number 2, I have to decide what is the values of t. So I'll put t is equal to negative 4. The traditional method, just the substitution, t is equal to negative 4. So equation number 2 implies minus 4 is equal to a into minus 4 plus 25 plus b into 0. That implies minus 4 is equal to 21a. That implies a is equal to minus 4 divided by 21. A is equal to minus 4 divided by 21. Okay, then next, put t is equal to negative 25. Put t is equal to negative 25. Yes, because the next factor is t plus 25. So put t is equal to negative 25. So if I put t is equal to negative 25, equation number 2 implies negative 25 is equal to a into 0 plus b into negative 25 plus 4. Answer, negative 25 is equal to b into negative 21. Okay, that implies b is equal to 25 divided by 21. 25 divided by 21. So a is minus 4 by 21, b is 25 divided by 21. This is what your answer is for the arbitrary constants a and b. Now I'll go for the equation number 1. Therefore, equation number 1 implies integral of t by t plus 4 into t plus 25 is equal to a is minus 4 by 21 divided by t plus 4, okay, and b is 25 divided by 21, 25 divided by 21 into t plus 25, okay, minus 4 by 21, t plus 4, 25 by 21, t plus 25. But I cannot continue the integration. I have to put back t is equal to x squared, because t is equal to x squared was substituted just to do partial fraction, not the method of integration. Method of integration can be done only by putting back t is equal to x squared, that is equal to minus 4 by 21 into integral dx by x squared plus 4, okay, and then plus 25 by 21 into integral dx by x squared plus 25. So I told you that there are three forms that can come in partial fractions. One is 1 by simple factor, 1 by repeated factor, 1 by quadratic factor, and 1 by quadratic factor is always 1 by a tan inverse x by a. So 1 by a tan inverse x by a, this is actually 2 squared, this is actually 5 squared, so that is equal to minus 4 by 21 into 1 by a tan inverse x by a plus 25 by 21 into 1 by a tan inverse x by a, tan inverse x by a. So that is equal to minus 2 by 21 tan inverse x by 2 plus 5 by 21 tan inverse x by 5 plus c. Easy. So in the integration part, only three results you have to remember. 1 by simple factor, which is log of the simple factor. 1 by repeated factor, which is repeated factor power n minus n plus 1 by minus n plus 1. And 1 by quadratic factor, which is 1 by a tan inverse x by a. So only those three forms. So you, in this first topic of particular functions and the second topic of partial fractions, why I'm asking you to concentrate more is, if a question comes, full marks. My method is fixed, nothing to do there. Directly applied, full marks. Okay, so this answer is clear, I guess. So let's go for the next question. Okay, here again, x squared by x power 4 plus x squared minus 2. Now I'm going to say this form here once again. It is going to be x squared divided by x power 4 plus x squared minus 2 plus x squared minus 2. Just now I told you we have to substitute x squared, right? So let's put x squared is equal to t. X squared is equal to t implies this is going to be x squared. Oh, sorry. It's going to be t divided by t squared plus t minus 2. Can you see that the denominator is a quadratic form? You could also use linear by quadratic here, but for me partial fractions is much easier because it can be easily factorized. It's going to be t plus 2 into t minus 1, and that is going to be a by t plus 2 and b by t minus 1. A by t plus 2, b by t minus 1. A by t plus 2, b by t minus 1. Call it equation number 1. And then method is multiply, right? The same old method, multiply it up, what you get? That implies t is equal to a into t minus 1, b into t plus 2. A into t minus 1, b into t plus 2. This is what you get. Start putting the values here. Call this as equation number 2. So we'll put t is equal to 1. If I put t is equal to 1, that implies 1. Equation number 2 implies 1 is equal to a into 0 plus b into 1 plus 2. That implies b is equal to 1 by 3. b is equal to 1 by 3. The next factor is obviously t plus 2, where you will put t is equal to minus 2. Put t is equal to minus 2. If you put t is equal to minus 2, equation number 2 implies minus 2 is equal to a into minus 2 minus 1 plus b into 0. b into 0. That implies, so a is equal to 2 by 3. a is equal to 2 by 3. So b is equal to 1 by 3, a is equal to 2 by 3. Now I'm going back to the equation number 1. Equation number 1 implies the integral of t by t plus 2 into t minus 1. Remember, I did method of substitution just for doing partial fraction, not integration. So I have to put it back. That is equal to integral. A is 2 by 3 divided by t plus 2, and then b is 1 by 3, integral of 1 by 3 divided by t minus 1. Substitute t, all of you. Substitute t here. T is equal to x squared. T is equal to x squared. That's going to become 2 by 3 integral of dx by x squared plus 2 and 1 by 3 integral dx by x squared minus 1. Okay, x squared minus 1. Okay, that's going to be like 2 by 3 into 1 by a. A is root 2 squared, all of you. This is not simply 2, it is root 2 squared. So 2 by 3 into 1 by a, tan inverse x by a. And 1 by 3, okay, this is going to be 1 by 2 log mod x minus 1 by x plus 1 plus c. This is because this one, the last integration, is a very, very rare occurrence. It's like 1 by x squared minus a squared form in particular functions. 1 by x squared minus a squared, it's 1 by 2a log mod x minus a by x plus a. Log mod x minus a by x plus a. Okay. So, I believe everybody is clear with this question. We'll just do one more question for this type, and with that we can wind up this class. Okay. This is a very, very important question here, my dear students. A very, very important question. A very, very good question for 4 marks. Here the problem is everything is x squared. Numerator, denominator, everything is x squared. So when you look at it, you have to do something here where I told you when sometimes the numerator could be having a degree which is greater than or equal to the denominator. Okay, that kind of a question it is. So it's going to be like, again, put x squared is equal to t. If I put x squared is equal to t, that implies the question is going to be t plus 1 into t plus 4 divided by t plus 3 into t minus 5. Okay, t plus 1, t plus 4 by t plus 3, t minus 5. So that is actually, you can't directly split it, because you can see that this is t squared plus 5t plus 4 divided by t squared minus 2t minus 15. This is the form, and you have to understand that here the degree of numerator equal to the degree of denominator. So here partial fraction method is not going to work, my dear students. The method of partial fraction is not going to work because the degree of the numerator equal to degree of denominator. In this, I explained to you, you have to divide. What are you going to do? You're going to divide the two polynomials. What is the first polynomial? T squared plus 5t minus 4 is divided with t squared minus 2t minus 15, and that is going to be anyway only once, because it is t squared and t squared. Your quotient is going to be 1. So it's going to become t squared minus 2t minus 15. Change the sign, my dears. Okay, this is going to become negative, positive, negative, positive. So it's going to be cancelled like this. So the answer is going to be 5t plus 2t, 7t, minus 4 plus 15 plus 11, 7t plus 11, 7t plus 11. All of you please look at it. T squared cancels. 5t plus 2t is 7t. Okay, and you have, okay, 7t plus 11. So what is the form that I told you? What is the form that I told you? F of x divided by g of x can be written as quotient plus remainder divided by g of x. This is what you need. Quotient is 1. Quotient is 1. Okay, this is the remainder. This is the remainder, and this is my g of x. Okay, so that is equal to remainder 7t plus 11 divided by g of x, which is t squared minus 2t minus 15. Please, all of you go back. All of you please go back to the video, and you can find that whenever you have these two parts, the first part is normal integration. The first part is normal integration. The first part is normal integration. But the second part is what? The second part is partial fractions. The second part is partial fractions. Okay, so I'm going to do the partial fraction part first, and then I will come back and do this answer. So let's call this equation star. Let's call this equation star. So let's go for the partial fraction factor first. All of you, let's go for the partial fraction now. The partial fraction part is 7t plus 11 divided by t plus 3 into t minus 5. Simple factors is a by t plus 3, b by t minus 5. A by t plus 3, b by t minus 5. So what are you going to do with the denominator? What are you going to do with the denominator? Multiply? Yes. After you multiply, what do you get? 7t plus 11 is equal to a into t minus 5, b into t plus 3. A into t minus 5, b into t plus 3. Start substitution. Start substitution. Okay, call this equation number 1. Call this equation number 2. So you're going to do that. So t is equal to 5. Therefore, equation number 2 implies 7 into 5 plus 11 is equal to 0 plus b into 5 plus 3. 7 5s are 35. 45 plus 11 is 46. 46 divided by 8 is equal to b. 46 divided by 8 is equal to b. That implies b is equal to 23 divided by 4. b is equal to 23 divided by 4. Again, look at the next factor. Look at the next factor. T is equal to negative 3. T is equal to negative 3 makes it 0. So equation number 2 again. Equation number 2 implies 7 into negative 3 plus 11 is equal to a into negative 3 negative 5 plus 0. Plus 0. That is minus 21 plus 11 is minus 10. Minus 10 is equal to minus 8a. That implies a is equal to 5 by 4. A is equal to 5 by 4. I got b, I got a. Now I can go back for equation number 1. I can go back for equation number 1. What is equation number 1 now? Equation number 1 implies 7t plus 11 divided by t plus 3 into t minus 5 is equal to a is 5 by 4 divided by t plus 3, b is 23 by 4 divided by t plus t minus 5. And we know that t is x squared. Here we know that t is x squared. Substitute it. That is equal to 5 by 4 divided by x squared plus root 3 squared. 23 by 4 divided by x squared minus root 5 squared. X squared minus root 5 squared. So this is going to be substituted in equation number 1. Yes, it's going to be substituted in equation number 1, all of you. It's going to be substituted in equation number 1. So equation number star implies integral of 1 dx, okay, plus 5 by 4 into integral of dx by x squared plus root 3 squared plus 23 by 4 integral of dx by x squared minus root 5 squared. So the first part, integral of 1 with respect to x is x plus 5 by 4 into 1 by a tan inverse x by a. It is 1 by x squared plus a squared. Particular function 1 by x squared plus a squared. Then 23 by 4 into 1 by 2a log mod x minus a by x plus a plus c. That is a particular function 1 by x squared minus a squared. It's a particular function 1 by x squared minus a squared. So we are ready with the final answer. X plus 5 by 4 root 3 tan inverse x by root 3, okay, plus 23 by 8 root 5 log mod x minus root 5 divided by x plus root 5 plus c. Okay, this is the final answer for this question. So this is the type of question which we had to do. First, substitution for x squared is equal to t. Then we have to do division because of the problem with the degree. So whenever there is a problem with the degree, we have to do the polynomial division. So with this, we have come to the end of this session and we are going to the next topic in the next class. Okay. So thank you everybody.
Brilliant Qatar, your trusted coaching partner for IIT, JEE, NEET, Science and Commerce tuitions with 10 years of excellence in quality training. Brilliant Qatar.